here we go. Big day, continuity. Continuity is super, super important, okay? What we want to talk about is this. For example, let's say we have an equation and you have a point. You want to find the line tangent. You need to find the slope. And you have, say, x to the third plus 2x minus 4. And you're like, hey, I wonder what the slope is at x equals 1. Cool thing, I can look at that and I can tell you the slope is 5. Boom, done. Wish you knew that, didn't you? I'm going to teach you how to do that and how to know that the slope is 5 that quickly, okay? I promise. But in order to make that happen, we got to finish stuff off. We need to talk about behavior of functions. And number one, we like to deal with calculus with functions that behave nicely. The definition of continuity, the dumb definition we don't write down in math books, is this. If you can draw it without picking up your pencil, then it's continuous. So that first one on the bottom there, that's continuous. The next one, not. Next one, not. Last one, not. Those are not continuous. If you can draw it without picking up your pencil, then it's continuous. But in mathematics, we like to give a different definition. And the definition for continuity is this. A function f is said to be continuous at a number a if the limit as x goes to a of the function is equal to f of a. A lot of people don't know what that means, and so we break it down into 3 criteria. In order for a function to be continuous at a given point, number one, this must be true. F of a must exist. Meaning, if you plug in a, you better get an output. If you don't get an output, does it make sense that it wouldn't be continuous? Number two, the limit as x approaches a of the function must exist. If the limit doesn't exist, it would mean that the limit is different from the left than it is from the right, or something of that nature, and then obviously you would have to pick up your pencil and draw it. It would be discontinuous. And the third one is to really put that together. The limit as x approaches a, so number 2, of the function must be equal to the first part, f of a. Number 1 must be the same as number 2. Now, if they are discontinuous, they will all obviously fail number 3, but we're going to focus on 1 and 2. So let's go over a first example here. Let's look at this graph. Can you tell me the x values for which this function is discontinuous? -5, 1. Good. Now what we're going to do is we're going to state the reason why they are discontinuous. Which one does it fail to meet? And so I always start with the very first definition. Those 3 definitions up there, you have to know those for the test, okay? Because you have to know them if you're going to be able to identify this. Make sure you know them. -5. Does f of -5 exist? What is it? It's 3. Does f of, or does the limit as x approach -5 exist? Yeah, it does. What is it? It's 7. Are those the same? No. So, it satisfies number 1. F of a exists. It satisfies number 2. The limit exists. But it does not satisfy number 3. So it fails number 3. Now you're like, well, how would you fail number 1 or number 2? Well, let's look at those. Let's look at x approaching 1. Does f of 1 exist? If you plug in 1, do you get an output? What do you get? 6. Does the limit exist as x approaches 1? Why? Yeah, it's -3 on this side and it's +4 on this side. Those are different, so it fails number 2. And then finally, let's look at 4. Does f of 4 exist? If you plug in 4, do you get an output? No, so it fails number 1. Now, obviously, you could say it fails number 3 for all of them, but that won't cut it, folks. You got to state it in the order in which they fail. Okay, so start with 1, then 2, then 3. Can you do that on the test? Awesome. Then you're ready to get an A. Flip it over. I don't like problem 2, so let's skip it. Go to 3. Sure. Exactly. It's like this internal feeling. It's like if we didn't cross it off, it wouldn't be any different, but you like to just cross things off. You must be a list maker. Okay, all right, never mind. Explain why the function is discontinuous at the given number a. Sketch a graph of the function. Look at this function. F of x is x squared minus 4 divided by x minus 2. If you remember, this function wants to look like x plus 2. It wants to look like x plus 2, but it doesn't look exactly the same. Why not? It's undefined at 2, exactly. So if I were to draw this graph, it's undefined at 2, meaning it has an open circle right there, right? Does anybody know what the height of it is at that open circle? How do you know it's 4, other than looking at the graph? Yeah, just plug 2 into what it wants to be. Okay, so it is discontinuous at 2. The question is, explain why it's discontinuous. So we've sketched the graph. Now let's answer the question. Does f of 2 exist? No, so it fails number 1. And you can simply write that. You don't have to write f of 2 does not exist. You don't have to write that, okay? You can simply write fails number 1 as long as you've provided this information on the test so far, okay? So you can just simply write that. I'll allow that. So let's go to B, okay? I got a piecewise function. Good thing, because you guys are really good at piecewise functions. You like them. So I plug in 0. What do I get? 1. Open or close circle? Open circle. And I'll head off at a slope of 1. There we go. Square root of x, I plug in 0, you get open or closed circle. Closed circle. Takes off like so. So I start with the very first condition, which is, does f of 0 exist? Yes. Does the limit as x approaches 0 exist? No, it's different from the left than it is from the right, so it fails number 2. Yeah, you need to be able to provide the correct graph. But you're really good at that, and you love piecewise functions. So, no, you're absolutely right. Coming up with the graphs is going to be the hardest part of your assignment today, and it'll be the hardest part for you to focus on. So we want to make sure we get that. We need to improve in our graphing. I think we all agree. So, all right, this is the last example we do for the day. Then we're done. You can work on your assignment. So the following functions have a removable discontinuity for a point A. Fill the discontinuity by writing a piecewise function. Here is something that's super important because it pertains to our ability to move forward in calculus all the way forward. X plus 3 times x minus 3 over x plus 3. This function wants to look like what? X minus 3. I mean, it really does. It looks every bit of x minus 3, except I love if people say you didn't draw a straight line. Is there any other kind of line other than a straight line? Okay, you know, you can't be this class anymore, dude. All right. Okay, so x minus 3 looks like this. Everybody agreed? Thank you. This is the point I want to make. See if you guys understood. So it's discontinuous at x equals -3, right? I know -3, but what about the y value? Well, if I simply take that -3 and plug it into what it wants to be, that would tell me -6. See that? So I will write a piecewise function that fills the discontinuity. F of x is equal to x squared minus 9 over x plus 3 for x values not equal to negative 3. So what I'm saying is, let the function equal this rational guy for all values not equal to negative 3. But when it is equal to negative 3, what should the output be? What should the output be? So I then fill this in. Negative 6. And when you can fill that discontinuity, that becomes the amazing thing about being able to find that slope and not having to use our limit stuff. Okay? Right here? Yeah. Am I not good enough? Okay. All right. Yeah. So this is, so just the black function is this part. But now that this red part, that's what happens when you fill it in. Yep, that's saying f of negative 3 is negative 6. Good question. Let's do one more. Okay, first of all, let's figure out what this thing wants to look like. Does everybody agree it's not defined at x equals 1? So I should figure out what it wants to look like. What do I do? How do I simplify that? It's a removable discontinuity. Difference of two cubes, right? So I have x minus 1, square the front, square the back, and it's always plus. Multiply the two, x, and it's opposite this sign. That's how we do difference of two cubes and sum of two cubes. Divided by x minus 1. What happens? So it wants to look like that quadratic, okay? So I will write the function. The function will be x to the third minus 1 over x minus 1 for all x values except but if x is equal to 1, what value, what output would fill the hole, fill the discontinuity? 3. How'd you get 3, Maddie? Plug in 1 into what it wants to be. Exactly. Take out your calculator quick. I go into y equals, and I type in x cubed minus 1 divided by x minus 1. And as I zoom as a decimal number 4, watch what happens, folks. Look at my graph. Do you see as I move to x equals 1? Do you see that there's a gap right there? Boom. Bunch of 1, there's a gap, right? So look at the y value beforehand, 2.71. Look at the y value afterhand, 3.31. So what was going to fill the spot? 3 is what fills the spot. We were able to figure out algebraically. Now, last thing, if you didn't know how to do the difference of two cubes, do you know how else to do that? Synthetic. Your solution is 1. 1, 0, 0, negative 1. Divide it. 1, 1, 1, 1, 1, negative 1, whoop, 1, 0. So you got x squared plus x plus 1. So this is the difference of cubes. This is using synthetic. Either way, it works out. What's your assignment? It's right here, folks. We'll write it down when we get back, okay? Have a good one.